Alright, hello boys and girls. Welcome to Here's Homeschool Academy. This is grade 4 Science and Technology. Alright, so we're going to be talking about week number 2, part of the curriculum, which is going to be an opportunity for you to do a scientific experiment to measure certain things about the physical properties of matter. Well, what is this experiment going to be all about? The experiment is going to be all about determining the mass of matter. So if you remember the mass of ice, so if you remember from last week, we talked about the different properties of matter, and determining mass or the mass of matter is going to be a physical property of matter. And we want to give you an opportunity to do a local experiment in your home together with your mom or your dad to determine the mass of matter. Well, what's that matter that we're going to be talking about today? Well, you're going to be determining the mass of ice, okay? Scientifically. You want to see how heavy your ice is going to be. And then you are going to compare the mass of water and ice, okay? And you are going to document empirically what your conclusion is going to be. You are going to document and find out that, well, mass really doesn't change with state. All right. So every scientific experiment is going to follow the same procedure, or is going to follow the same kind of structure that I'm going to be sharing with you today. What is the structure of a scientific experiment? Well, the structure of it is there is an objective, which we captured over here. Well, this is what we want to do. We want to determine the mass of ice. We want to compare that with the mass of water, and then we want to document our conclusion based on that. Now, right after the objective, you are going to be following through a scientific procedure. Okay, then right after the procedure, you are going to document your observation, which is what you observed when you conducted your experiment. Okay, so just a little experiment for you that you can do over there, and then you are going to draw your conclusion scientifically. All right, so let's try to get started. All right, so why don't you go ahead and fill up a bowl, a little bowl with water. Right, so let's try to take a look at it. So what we're going to do right now is we're going to get our water. Let's try to get our water here. Okay, so you're going to get a little bowl like that. Okay, and what you're going to do is you're going to try to determine the weight of this bowl firstly on a scale. So you can use your mommy's scale over there. And you're going to see that little scale over there. So let's try to determine the weight of this bowl by placing this bowl on this scale. So put on the scale and determine it. So let's assume that the bowl actually weighs, all right, so let's say weight of bowl is going to be equivalent to 0.4 ounces. Okay, so that's the weight of our bowl. Okay, when we put the bowl on a scale, it weighs 0.4 ounces. Now we're gonna fill this bowl with ice. Okay, so if you have like your ice dispenser from your refrigerator, so just go ahead and fill it up with ice. Fill it up as much as possible. Make sure it's completely full of ice, full of ice, and full of ice, and full of ice, just like that. Make sure there's no space over there. We're trying to do an experiment in here to determine if the weight of matter is going to change with the state. Okay, so we're going to fill up the bowl with ice, and then we're going to take the bowl full of ice, and then we are going to put it on a scale one more time and determine this time around the weight of the bowl and the ice. So let's say that we did that, and then B2, which is going to be the weight of ice and bowl, let's say that's going to be approximately equivalent to 8 ounces. Alright, so just get any bowl that you can play around with and try to do this experiment, okay? So we've done that. So B2, which is like the the weight of the bowl and full of ice, put it on the scale over there. Well, you got 8 point or just 8 ounces. Now let's empty out the bowl, and then we're gonna try to fill the bowl with just water right now. Okay, let's try to fill the bowl with water. Okay, so this is just gonna be water and water and water. And you're gonna take it over there and then put it on the scale. Okay, put it on your kitchen scale over there and call that B3. All right, so B3, when you fill it up with water, you're gonna see exactly that. Well, it's gonna be approximately 8 ounces as well. Okay, depending on the size of your bowl. So now the question is, what is the weight of ice? The weight of ice is going to be equivalent to, guess what? It's going to be 8 minus 0.4. And if you do that, what's that going to give you? 8 minus 0.4, that's going to be 7.6 ounces. All right. Now let's try to find the weight of water. So this time around it's going to be B3. So we did B2 over here. So this is B2. Okay. B2. Okay. Minus the weight of the bowl. Now the weight of water is going to be pretty much like the same thing as well. 8. Okay, minus 0.4. Okay, and guess what? That's going to be approximately equivalent to, guess what? That's going to be 7.6 as well. So the mass of water, even though you technically call it weight, but it's actually mass, is the same thing as the mass of ice. Can you see that? Well, what does that tell us? The weight of an object does not change, or the mass of an object does not change regardless of its state. So that is our little experiment. So you're going to document the mass of your ice over there. You're going to document the mass of the empty bowl, document the mass of bowl plus water, and then document the mass of water. And then your conclusion is going to be that, well, the mass of water is the same as the mass of ice. Therefore, guess what? The mass of matter does not change with its state. Alright? So that's a pretty cool experiment you can do to validate that conclusion over there. To validate that the mass of an object does not change regardless of whether the object is going to be in the liquid state or in the solid state, and potentially in the gaseous state. If you have a way of collecting like the steam coming out of your water into a balloon, that may be a little bit too sophisticated for you over there, and you were to measure the weight of that balloon on the scale following that procedure we talked about, it's going to be exactly the same mass of water as well. Okay, so please go ahead and try to do that, and let your mom or your dad walk you through that fun experiment over there, and turn to page number 10 to document your observations and your conclusions. That is how to do a scientific experiment. Those are the basics of it: the objective, the procedure, observations, and then your conclusions. All right. Did you get something from it? I sure hope so. Well, thank you, boys and girls, for joining me today. Remember, God cares about you, and so do we. Bye-bye.
I'll be your hero's buddy, and as you study with heroes born, I will be your friend. So don't you worry.